Good afternoon, dear colleagues, but especially to the videos aimed at the apprentices of cathodic protection. I want to present to you an extremely rare and difficult to detect case. It's very rare, this type of problem. It's very uncommon. Before we dive in, don't forget to subscribe to my channel and turn on notifications to stay updated with my content. And I want to explain and share my experiences and knowledge, especially with the apprentices. Remember that all of this has an educational purpose. For all my colleagues who want to get started in this field, assessing a cathodic protection system, there are potential drops. Insulation check showed it was good. Used old school methods, multimeter, tester, and 3 techniques to confirm current blockage. When I checked this tubing that goes to a pressure transmitter, I checked this insulation with the insulation checker, and it showed that it was good. However, I had to apply the old school methodology using a multimeter and a tester, confronting 3 different techniques to really determine if that was actually blocking the currents. The insulation check indicated that it was fine. Here I have my relationship checker, but it's a very minimal electrical contact, very minimal, and it allows me to transfer the potentials. Look, excuse me, look, when I measure the potential before the insulation, I have a potential of 1411 millivolts. Okay, but when I measure it after isolation, I have the same potential. It's allowing the cathodic protection to pass through. When I check the current, let me set the clamp here. Remember that I don't have an assistant for this. The clamp is telling me that I have 0 current, but that's because I have the grounding disconnected. But when I connect the grounding, which I'm going to do simultaneously so you can see, it's allowing 400 milliamperes to pass through. If you see, I disconnect it, I'm going to disconnect it, notice my foot, and the clamp goes to 0. But when I connect the grounding, which I'm going to do simultaneously so you can see, it's allowing 400 milliamperes to pass through. If you see I disconnect, I'm going to disconnect, notice my foot and the clamp goes to 0. If I ask what current it's allowing to pass, I reconnect it, look at my foot and the clamp, excuse me, 0, 9 amperes, 900 milliamperes in AC. I disconnect, notice my foot when I disconnect, and the clamp falls. Now see how the potential affects me. When I connect the grounding of 1300 millivolts, it drops it to 387 millivolts. Notice that I'm going to disconnect it so you can see how the cathodic protection system reacts. It rises to 1384 millivolts. It's transferring the cathodic protection to the grounding system. It is a rare and difficult case, but it is good to take precautions when there are potential faults that do not comply with the protection criteria. Take these precautions to carry out these more exhaustive inspections of the control systems and systems of whether they be pressure transmitters, temperature transmitters, because sometimes, look, this was causing me a serious problem in the protection that I touched, and this is a transmission line. Dear colleagues, I hope you have a very good morning, very good afternoon, and a very good evening. It's been a pleasure to share knowledge with you again. I hope this helps the other colleagues